Okay, in Algebra 2, this is a Chapter 2 practice test from page 159, numbers 1 through 18 all. This is to get ready for the upcoming Chapter 2 test. Okay, when you're multiplying like bases, you add exponents. So if 3 plus 2 makes 5. Now when you multiply again like bases, you add exponents, you get 1. So the answer is x to the first. On number 2, this is powers to powers. That means you multiply your exponents. So this would be 2 to the 1 times negative 5 is negative 5. X raised to the negative 2 times negative 5 is positive 10. Y to the 3 times negative 5 is negative 15. It's always over 1. If there's any positive exponents, like x to the 10th, they stay where they are. If there are any negative exponents, they simply move to the other side of the fraction and become positive exponents. So your answer is going to be x to the 10th over, I believe 2 to the 5th is 32, y to the 15th. And again, a power to a power, you multiply exponents. So negative 4 times negative 2 is a positive 8. Y raised to the 2 times negative 2 is negative 4. Any positive exponents stay where they are. Any negative exponents go to the other side of the fraction and become positive. So this answer is x to the 8th times y to the 4th. Okay, we did 1, 2, 3. Let's take a look at 4. We're still simplifying. Notice that 3 is just to the first. So this would be, and these are to the first. So the 3 is not raised any power, but the x and y are raised to the third. 1 times 3 and 1 times 3. On bottom, you have 27x minus 5y cubed. I don't believe I can factor anything out of the bottom. Some people will try to simplify these, but the 27 is not multiplied by everything on the bottom. So you really cannot simplify it. I think that's all you could do to it. I'm not sure I like that question. It's pretty simple, but... Now, number 5, we want to graph. If you're going to graph, I strongly suggest you make something called an XY table. Always put in 0. If you put in 0, you have negative 0 cubed, which I believe is 0, so this will go through 0, 0. If you put in a 1, what would you get if you put a 1 in and cubed it? What would y equal? Y would equal 1, but then you'd have to multiply by the negative, so I believe you'd get a negative 1. So you'd have 1, negative 1. What if you put in a 2? If you put in a 2, what is 2 to the third? Well, it's 8, and then multiplied by a negative is negative 8. So you'd have 2, negative 8. How about if you put in a negative 1? What happens if you put in a negative 1 and then you cube it? That gives you a negative 1. A negative times a negative makes it a positive 1. So it would go through negative 1, 1. If you put in a negative 2, you'd get the negative of a negative 8, right? If you're putting in a negative 2. So I believe that gives it an 8. So it's going to go through negative 2, comma 8. And it's going to look a lot like the cubes do, where you have in the endpoint behavior is going up to positive infinity, down to negative infinity. But it has a negative, so it's flipped over from the normal x cubed. But I always recommend an XY table, especially using 0. Again, graphing, I think is best to make an XY table including 0. This is a 4th power. I know what x to the 4th looks like. It's either like this or like this if it has a positive leading coefficient. So I know it's going to look something like one of those. I'll make an XY table, and I'll probably put in the 0. If you put in a 0, you get 0 minus 0 minus 0 plus 1. That makes y equal, I believe, 0 minus 0 minus 0 plus 1 makes y 1. So when I graph this, this is going to go through 0, 1. I won't make too many points on the x, so I'll just increment it a little bit. I probably won't increment too much of my y-axis because I think it's going to change pretty rapidly. If you put in a 1, excuse me, if you put in a 1, what happens? Let's see. And again, here it's to the 4th. So if you put in a 1, a 1, and a 1, what do you get? 1 to the 4th is 1. That'd be minus 2 and minus 5. So you get negative 7 plus 2, I believe negative 5. So it's going to be at 1, negative 5. Let's try putting in a 2. I'm going to now put in a 2. 2 to the 4th is 16. 2 times 2 is 4, times that 2 again is 8. 5 times 2 is 10. So you have a negative 18 plus 17. I think that becomes a negative 1. So I know it's going to go through these points. If I try a negative 1, let's see what happens. Maybe I'll have to go to 2. Again, I'm not looking for extreme accuracy. I'm looking for the curvature, where it's going to go, in behavior as well, which I showed you right here. We're going to put in a 2 this time. I'm sorry, how about a negative 1? Let's put in a negative 1. To the 4th is a positive 1. That's a 2 times a positive 1 becomes 2. 5 times 1, 5. So we have a negative 7 plus 2, which I think is a negative 5. So let's see what we can do with this. 1, 2, 3, 4, 5, negative 5. So we have a 1, negative 5. And we have a negative 1, negative 5. Put in a 0, gave me a negative 1. If I put in a 2, it gave me a negative 1. So 2, negative 1. I'll bet if I put in a negative 2, I would also get a negative 1. So I have a feeling it might look something like this. Because it's a 4th degree, if I drew a horizontal line, let's say I drew a horizontal line here, at most, how many times would it touch it? Hopefully that corresponds to the degree of the polynomial. Now it's going to look close. Again, I'm mainly looking for n behavior and plugging in the 0 and such stuff like that. Yes, you're absolutely correct. When I put in a negative 1, I don't believe I get this. This should be a plus 5 here. So what does this give me? 7 minus 2. I think it makes this a 5. So my graph is obviously not quite right. Let's see if I can fix her up. Give me a moment. I'm just reworking my XY table. If I put in a 0, I get a 1. If I put in a 1, I get this, I believe. So that's negative 7 plus 2. Is that negative 5? So I think I had these right. If I put in a 2, let's see what you get here. 2 to the 4th is 16. That'd make that an 8. And if I put in a 2, that would make that minus 10. So let's make sure I put in a 2 is 16, 8, 10. So I have 16 minus 18, which is negative 2, plus 1 is negative 1. So I think I had those points right. Now if I put in a -1, what did we get out? Was it a 5? Let's verify again. If you put in a -1, that's going to be a 1. -1 is going to make this. -1 makes +5, +1. So 2, yeah, it gives me a 5. So let's try a -2. -2 to the 4th is a +16. -2 squared is a 4. So far I have this. If I put in a -2, I think that's +10. So you get, what is this, 18, 19, I think? So you have these points. So you have -2 comma 19, which is way up here. -1 comma 5, which is about here. 0, 1, 1, -5, and then 2, -1. So I know it's coming down, and I don't really know if it curves back or not. I could use a graphing calculator, or I could extend my table, but again, I'm mainly looking for end behavior and intercepts. I don't quite have it going through there, but same thing with 7. What is the end behavior on an odd function? Do you remember odd functions look like this? So what is the end behavior? Down and up? And if I put in a 0, what would I get? -9. So I'd have 0, -9, and this is a positive, so I know it's going to look like that. So it's probably going to look like this. It might have more curves to it, but the end behavior will be the same. And I'll be happy with that with a sketch. Feel free to do an XY table if you want more accuracy. It never hurts. Okay, I checked the graphs using the graphing calculator, and they do look pretty similar to these. Okay, we're going to do this simplification, basically combining like terms. So I need to combine 2x to the third plus 1x to the third, which would make 3x to the third. 5x squared and a -3x squared makes 2x squared. -7x plus and a -4x is -11x. 4 and nothing else is 4. So I believe I've combined all my like terms. Now, addition is a little easier than subtraction. Subtraction, you have to distribute your negative and add, or just change your signs and add. So that's going to become -x squared, -4x, and a +8. Combining like terms, 3x to the third is the only x cubed. -4x squared, -1x squared becomes -5x squared. 3x and a -4x is a -1x. Then -5 and a +8 is a +3. So we've basically simplified these expressions. Okay, we're going to go for these are addition, subtraction. Now we're going to have some multiplication. So I'm going to distribute 3x times x squared is 3x to the third. 3x times 4x is 12x to the second. 3x times a -7 is -21x. Now I want to distribute a -2. -2 times x squared is -2x squared. Please notice that I'm lining up x squareds with x squareds. -2 times 4x is a -8x. And -2 times -7 is a +14. Now I'm just going to combine like terms. So I get 3x to the third. I think that becomes +10x to the second minus 29x plus 14. And that's what you should get for number 10. In 11, you have a quantity cubed. I hope you're aware that if it's to the third, that means one of them times the other one squared. You could write it out all 3 times and distribute if you wished, I'm kind of hoping you'll learn the rules for squaring a binomial. Square the first, multiply these and double it, so that's negative 15x doubled is negative 30x. Square the last is 25. You could get that also by writing it out twice and foiling it or distributing it. But again, I'd prefer you to learn the rule, square the first, square the last, twice the product in the middle. Anyway, now I'm going to distribute 3x. So let's do this. 3x times 9x squared is 27x to the third. 3x times negative 30x is negative 90x to the second. And 3x times 25 is 75x, I believe. Now I'm going to distribute a negative 5 times 9x squared is negative 45x squared. Again, notice how I'm lining up my squared terms. Negative 5 times negative 30x is a positive 150x. Negative 5 times 25 is negative 125. We're going to combine like terms. You have 27x to the third. This would be, looks to be negative 135x to the second, plus I think that's 225x minus 125. Now we've expanded that binomial. Okay, we've done some addition, some subtraction, some multiplication. I assume division should be coming, so here's some division. This one, you'll notice, has an integer solution for this. Because it has an integer solution, that lends itself to synthetic division. Whereas number 13, that is not an integer solution right here. If I tried to, it might be two integers, but there is not one that I know of. That one I have to do long division. So if it's okay, I'll probably do 12 synthetic and 13 long. You can do them all long, but this one kind of lends itself to synthetic. Are all powers represented in decreasing order? X to the fourth, there is no x to the 3, is there? X to 2, x to 1, x to the 0. So I have to make an x to the 3. So you have 6x to the fourth plus 0x to the 3 plus 7x to the 2 plus 4x minus 17. Now all the powers are represented decreasing order. I bring down my coefficients. 6, 0, 7, 4, 17. I leave a space, I draw a line, and I make a box. Of course, 13 is not the one for synthetic, so never mind. That would be 12 is the one for synthetic. Are all these powers represented in decreasing order? X to 3, x to 2, x to 1, x to 0. So now I can bring these coefficients down. 3, negative 14, 16, negative 22. Leave a space, draw a line, make a box. The number that goes in the box is going to be whatever makes this 0. So I'm going to put a 4 in there. After you've done a few of these, you get the process down. The 3 comes down. Then you multiply 3 times 4. 3 times 4 is 12. You put it here and add. So if I add these two, I get negative 2. Multiply is negative 8. Put it here and add is 8. Multiply is 32. 4 times 8. Add gives me 10 for my remainder. So the answer is going to be 3x to the 1 less than this power would be 2, minus 2x plus 8, plus the remainder over the divisor. So that's number 12 done synthetically. You're right. 7, 8 here, but for some reason I put a 9. So I think it's because I'm trying to explain and talk and write, but I think it's supposed to be like this. Any questions on 12? Okay, again, this was easiest done by synthetic because this had an integer solution. I mistakenly started that on number 13, but it does not have an integer solution there. So I have to do this long division. So I have 6x to the 4th plus 7, actually let me put in a 0x to the 3rd plus 7x to the 2 plus 4x minus 17, all divided by 3x squared minus 3x plus 2. 3x squared minus 3x plus 2. Now I say 3x squared times what gives me 6x to the 4th? And that would be 2x squared, I believe. So that's what I put here, 2x squared. 2x squared times all three of these things. 2x squared times 3x squared is 6x to the 4th. 2x squared times negative 3x is negative 6x to the 3rd. Notice if I didn't put that 0, I wouldn't have a column to put that. And what's 2x squared times 2? 4x squared. In division, you change your signs and add. So change the signs and add. So what comes down here is 6x to the 3rd plus, what is that, 3x to the 2nd plus 4x minus 17. And I do it again. 3x squared times what is 6x to the 3rd? 3x squared times what is 6x to the 3rd? And that would be a 2x. So you'd have a positive 2x. 2x times 3x squared is 6x to the 3rd. 2x times negative 3x is negative 6x to the 2nd. And 2x times 2, I believe, is 4x. Again, in division, at this point, you change your signs and add. So what's going to come down now? 9x squared. Those will add to 0 and minus 17, I think, isn't it? Now, one last time. 3x squared times what is 9x squared? Well, 3x squared times 3 would be 9x squared. So a positive 3. 3 times 3x squared is 9x squared. 3 times negative 3x is negative 9x. And 3 times 2 is a 6. I don't know why I wrote a 9. 6. Change your signs and add. So what comes down is 9x minus 23. So that's your remainder. So you're going to put plus the remainder, 9x minus 23, all over the divisor, 3x squared minus 3x plus 2. And that would be your answer up here. Okay, let's go on to 14. We want to factor these. This is a sum of cubes. I know that if I could write this as a cubed plus b cubed, it would factor into a plus b times a squared minus ab plus b squared. That's one of my rules. This is the sum of cubes. So I need to write this somehow. What cubed is 8? Could 2x quantity cubed be 8 cubed? What cubed is 27? 3. So again, I know that if I have a cubed plus b cubed, that's going to factor into a plus b times a squared minus ab plus b squared. So what I need to do is write this out, put my signs, and fill it in. Okay, what is A? Can you look here and tell me what A is? 2x. What is B? 3. If A is 2x and I have to square it, squaring the 2 and the x makes 4x squared. Minus A times B, that means 2x times 3, or 6x. And plus B squared. If B is 3, B squared or 3 squared would be 9. So factored, this would be 2x plus 3 times 4x squared minus 6x plus 9. And again, that's using the sum of cubes formula. That's at the top here. That's this one. If you would like the difference of cubes formula, here it is. The only thing that changes is the sequence of the signs. So this one goes minus plus plus. So there's the difference of cubes. There's two formulas. 15, I notice, is a trinomial, 3 terms. Usually 3 terms, trinomials factor into the product of 2 binomials. So would x squared times x squared make x to the 4th? Now what's A times C on this thing? Negative 6. What's B? 5. What multiplies to this but adds to 5 would be 6 and negative 1. Because the A is a 1, I think I can put them right in. 6 and a negative 1. So x squared plus 6 does not factor. There is no rule for sum of squares in the reals. But x squared minus 1 is the difference of squares, so that factors a bit further. X plus 1 times x minus 1 is the way that one would factor. Okay, we have 14, 15. Let's take a look at 16. How many terms are in 16? 4 of them. No common factors. That usually means you split it. So what can I take out of the first two? An x squared. If I do, it'd leave me with an x minus 3. If I distribute, would I get x to the third minus 3x to the second? Now on the second two, I can factor out a negative 4, right? If I, or positive or a negative 4. But if I take out a negative 4, notice now they both have x minus 3's. So at this point, I'm going to factor out the x minus 3 times what would remain. Well, if I took those out, what would remain would be x squared minus 4. How does x squared minus 4 factor as the difference of squares? X plus and x minus 2. After 16, I think we're doing a couple finding the zeros. If you remember from 2-6, the zeros I will always make them a factor of this last constant. So you have factors of 40, positive negative 40, 1, 20 times 2, 3 doesn't go in there, 10 and 4. I'm sure 8 and 5, positive negative 5. Anyway, out of all these, at most 3 will work. So I'm going to bring my coefficients down. All my powers are represented in decreasing order. And I'm going to do synthetic division on it until I get my remainder to be a 0. I always tell you to start with the small numbers. So I'm going to start with a 1. Bring the 1 down, multiply. 1 times 1 is 1. Put it here and add. 1 times 2 is 2. Put it here and add. Multiply 1 times negative 20 is negative 20. Do those add to 0? No, so I'm not going to use 1. Since I tried 1, now I might try negative 1. Bring the 1 down, multiply. Negative 1 times 1 is negative 1. Add is 0. What's negative 1 times 0? 0. Put it here and add. Negative times that is 22. Does that add to 0? No. So I exhausted 1 and negative 1. What do I try next? 2 and negative 2. So I'll try 2. Bring the 1 down, multiply 2, put it here and add, multiply 6, put it here and add, multiply 32, put it here, negative 32. Does that add to 0? So I've tried 1, now I'm going to try 2, 2 didn't work, so I'm going to try negative 2. Bring down the 1, multiply is negative 2. What do you get if you add here? Negative 1. Multiply is 2. Add is negative 20. Multiply is 40. Did I find one that worked? So what does that mean? That means you have x plus 2 times 1x squared minus 1x minus 20. I'll factor that a little bit further into x, what is it, minus 5 and plus 4. I think those add to negative 1 in the middle. So what makes each of these equal 0? And that would be my answer. So it's going to be x equals negative 2, negative 4, or positive 5. I think those are the 3 values that make this 0. Okay, we had to, basically I found the zeros by factoring it using synthetic division, which is what I'm going to have to do here. Factors of 6, positive, negative, 1, 2, 3, and 6. Out of those 8, at most 4 will work. Okay, so are all my powers represented decreasing order? X to the 4, x to the 3, x to the 2, x to the 1, and x to the 0. So I brought the coefficients down. I'll leave a space, draw a line, make a box. I may jump right to one that I believe might work, such as negative 2. You might have to try and error a little bit, just to find out which one works, like I did on the last problem. Bring the 1 down, multiply is negative 2. Add is negative 10. Multiply is 20, add is 1. Multiply looks to be negative 2. Add is 21, and multiply is negative 42. So this one did not work. I guess I was wrong. Let's try a positive 2, unless I made a mistake in my arithmetic. Let's try a positive 2. Bring the 1 down, multiply. 2 times 1 is 2. Put it here and add. Multiply is negative 12. Put it here and add. What is that? Negative 31. This doesn't seem to go to 0 either. Bear with me. Okay, I made a mistake in the way I wrote it down. This should be a 4x to the 4th. Okay, so I believe if I was to do this again, I'm hoping negative 2 might work. Bring the 4 down, multiply, negative 8. Add is negative 16. Multiply is 32. Add, what would this be? Is that 13? Multiply would be negative 26. Add would be negative 3. Multiply would be 6. And that gives me a remainder of 0. So far I know then that y equals x plus 2, because negative 2 makes that 0. 4x to the third minus 16x to the second plus 13x minus 3. Now I might have to do synthetic again, so let's try it one more time. 4, negative 16, 13, and negative 3. Now I need factors of negative 3. So if you don't mind, I'll just go to 3. If we put a 3 here, bring down the 4, multiply, that's 12. Add is negative 4, multiply is negative 12. Add is 1, multiply is 3, and that makes my remainder 0 again. So I have x plus 2 times x minus 3 times 4x squared minus 4x plus 1. That's going to factor, I hope. If not, I'd have to use a quadratic formula. But I think it's going to factor into 2x, 2x. What are factors of 4 that add to negative 4? Negative 2 times negative 2. So is it this? So you should have, the answer should be x equals negative 2, x equals 3, and when you make this equal 0 here, should give you x equals 1/2. That one involves synthetic twice to get it down to where you could solve it. Now you might like the bonus type I'm going to give you because they're pretty easy, I think. They're basically out of the next section, 2.7. Could you write a polynomial with these zeros? Here's how you do it. You always do x minus whatever the 0 is. So what is my first 0? Negative 1, 3, and 4. So you really have x plus 1. Does negative 1 make that 0? Yes. Does 3 make this 0? And does 4 make this 0? Then you just multiply it out, which we've already done. You multiply these, you get x squared minus 7x plus 12. X times x is x cubed. X times 7, there would be negative 7x squared. X times 12 is 12x. 1 times x squared, 1 times negative 7x, 1 times 12. Combining your like terms, you'd have negative 6 x squared, what would this be, plus 5x plus 12. And this would be your polynomial function with those zeros. Now if you ever get an I, you always have to remember that its conjugate is also a 0. So you're going to have x minus 6 because 6 makes it 0. X minus 2i because that makes that one 0. And x plus 2i, which is what makes this 0. Now I don't know, I told you there's no sum of squares for reals, but there is for imaginaries here, complex. So this would give me x squared plus 4, I believe. Feel free to distribute it out. Remember, I squared is negative 1. X times x squared is x to the third. X times 4, let's do this, would be negative 6x squared. X times 4 would be 4x. And how about last times last? Negative 24. So that would be the polynomial with these zeros. Anyway, this is a bonus type thing I would ask, but the main questions I would ask would be 1 to 18. I hope these help. Good luck.